start the recording. What's going on? Does it get confused with this? Okay. I'm hoping that it will gonna record this. Okay, so I'm gonna open a new one, which would be obviously week. Everybody's opening it, right? So it should be obviously week 13, lecture 2, right? The recording started already. All right, everybody ready? So our goal or title, let me put the title first. So title is week 13, lecture 2. Okay, while loop part 4 and symbolic math. Title description should be one last problem or a fuel economy while loop and intro to symbolic math. Okay, and you can put your name and everything, you know, the name, email, date, all sorts of things, you know that, right? I'm just skipping those. Let me start with those usual command that I usually use, like CLC clear and close all. And then let's start with this problem. So this problem, I would say example number 1, while loop, last example. Okay, let's start with the problem description. Let me go with one special problem description. So the fuel economy of your car is affected by the speed it is traveling. I'm sorry, it's going to the next slide. All right, by the speed it is traveling because of the drag force of air. Okay, given by the formula. So I'm giving you the drag force formula. You guys know what is drag force, lift force, rolling force? Okay, drag force is if something is moving, the resistance it get from the air. Okay, so let me give you the equation for the drag force. Ft equal 0.5 rho v square CD multiplied A. So calculate the force of drag on a car for all velocities from 1 to 155 mph. You know what is mph? Mile per hour, yeah. Okay, which is equivalent to, you know, this line like wiggle line, that means approximate, right? 70 meter per second. Okay, the electronically limited top speed of many sporty cars, right? So that's the speed, like max it can go up to 155. Usually it wouldn't go that fast. That's the sports limit, max limit, electronically possible. So what would be doing? We also want to account for rolling resistance. You know what is rolling resistance, right? The wheel with the rod, right? That's called the rolling resistance. So we can try to estimate the energy used, fuel consumption, the rolling coefficient C is given by C equal 0.005 plus 1 over P. Okay, I gotta go next line for this equation. That's the rolling resistance coefficient, okay? So 0.01 plus 0.0095 multiplied by V multiplied 3.6 divided by 100 square. Your parenthesis finished here, and there should be another one. Okay, perfect. Where P is tire pressure in bar, right? You know bar. You guys are familiar with the unit bar. 1 bar is equal to what? 1 atmospheric pressure. You guys remember, like 14.46 psi or 101 kilopascal, right? This is 1 bar. Actually, 1 bar is not 101 kilopascal. It's 100 kilopascal. Okay, to be exact. But it's equivalent to 101. That's the exact value. Anyway, okay, so in bar, and V is velocity in kilometer per hour. The force of resistance is given by Fr equal C multiplied M multiplied G, where C is the rolling coefficient, okay, M is the mass of the vehicle, and G is acceleration due to gravity. Alright, so that's the problem description. Let's start with the givens and then I'll talk more about the problem. Okay, so first of all, the max velocity, you can define a variable called Vmax equal, because remember the velocity is 70 meter per second. The sports car, that's what I was talking about it. Okay, so the unit is meter per second. That's the maximum velocity of interest, okay, meter per second. Alright, so then the rho, you guys know what is the rho symbol that people use? Rho is for density of air. So the value of density of air is 1.2 kg per meter cube. Obviously, I'd like to put the unit, so this is kg per meter cube, right? And there's the density of air. Alright, so then the CD, you guys remember what is CD? is the coefficient of drag, right? So CD is 0.355, and obviously like to put the note here. So the note would be it's obviously CD is the unitless, right? It doesn't have any unit, so unitless coefficient. And we'd like to explain this. So this is the coefficient of drag, coefficient of drag force. All right, and this value I can give you a reference. This was taken from reference is Ford Focus. You know, different car has completely different coefficient of drag, right, depending on the aerodynamic shape of the car. So this is for Ford Focus RS 2016 from Wiki. You know, Wiki means Wikipedia. All right, then the area. What is this area? This area is the estimate, the frontal area of the car, as if like you are doing a cross section of the car. You guys know what is the frontal area for drag force? You guys ever have the drag force calculation in any class anywhere? No? Okay, so let me explain a little bit. Then focus on this. See, this is the car, right? So, you know, drag force is like when air is moving around, the amount of resistance it experiences due to the drag. All right, so now you're moving the car, right? Or the air is coming, the car is still, either way you're going to experience some drag. Now, this CD goes with the drag force, like coefficient of drag, CD, that goes with the drag force equation. Okay, it's a unitless thing, right? I talked about it. Now, the area of the frontal area, there is an equation for that, by the way, drag force, that contains the CD, the A, the frontal area. So, what is the frontal area? Because the ER get exposed in the front side of the car, right? As if like you having a cross section here, you can cut it here and you measure the area when you cut it. Understand? You measure this area, this cross section area. That's why they call it frontal area. Okay? Understand? So that's the frontal area A. So A is 2.3, right? And you can obviously put some units and everything. So this is the unit is meter square, right? That's the estimate. All right, so then the P is the tire pressure. Now remember, it's in bar. I mean, you guys ever notice what is the tire pressure that you usually put in your car? Ever notice what is the tire pressure in your car? 40 is a lot of pressure. Are you sure you put 40? You drive a truck? Oh. It all completely depends on the manufacturer of the tire. Okay, tire manufacturer give the tire pressure in PSI. Usually it can go anywhere from 30 to, you said 40. Yeah, that could be your recommended value. Now my car, I usually put 35. If you're gonna go, stores, they usually have it set usually 35, but you can change the settings to whatever settings you want. But anyway, the reason I'm saying all of these things just for side notes, not too important with this problem, but the problem just says it's in bar. Now, 1 bar is 14.6 psi. That's the atmospheric pressure, right? So how many bars it would be? It would be 2 point something bars, because, right, depending on the pressure of the tire. So this Ford Focus, the tire, they use this pressure of 2.5 bar. Okay. You understand how the bar and PSIs are related, right? 14.6. All right. So that's in bar. These are fun facts. I'm just trying to share these things with you guys. Not necessarily very important with the programming. So this is the tire pressure, right? So tire pressure usually for 30 psi, you can say, you guys are familiar with this sign, right? The wiggle sign, this approximate, right? Approximately equal to 2.3 bar. Okay, I'm not using all the fraction, you know what I'm saying? All the decimal places. That's the 2.3 bar I'm using. So there's the tire pressure. Then the vehicle mass, 1600, and there's not that much to talk about it. 1600 kg, right? Where to get it? It's from the manufacturer. That's for Ford Focus, right? There's the mass of Ford focus RS with a driver, assuming there is somebody's driving with it, right? And then the drag will experience. G, anybody remember the G? Is the gravity, right? 9.81 and meter per second square. Oftentimes I see students give the number without the units. Don't ever do that in professional place. Give the number with the units, okay? If you give number without units, it will look like not professional. Let me put it this way. All right, so 9.81 obviously, and then you'd like to put the unit of this acceleration, which meter per second square for this 9.81 value for gravity, and then you'd like to write is the acceleration due to gravity. All right, and then few more things that you'd like to define on the givens, which are givens here as well. So ideal. So what does ideal means? Ideal is a variable for sure. When the car is in idle condition, you just turn it on, it's in idle condition, it's not running. What happened then? Then the fuel consumption is 0.16 gallon per hour. Okay. One time it happened when I was, after my MS, I was in job. I forgot to turn on. That time it was not like electronic push button switch or anything like that. Okay, long ago, back on 2007 or 2008, I believe. So I turn on. That's the car from office, right? Corporate car. So I turn on the engine. For whole night it was running. Okay. Next day came and the significant amount of gas got reduced, right? As you can see, like 0.16 gallon per hour. So several gallons are gonna go away if you just turn it and nothing happened, means you're not driving it. But it's much less than when you're driving it, by the way. Okay, so which is again gallon per hour. So there's approximation of fuel used at idle. All right, so then I'd like to define another variable called joule gallon, joule GAL. That's the way I'm writing. 130 into 10 to the power 6. What does it mean? It means that first of all, the unit of this thing is very straightforward, joules per gallon. So this is the energy density of gasoline. Okay. And the efficiency is 0.2. So the efficiency of gasoline engine. Okay, then FT equal NAN. You guys remember NAN? Anyone? What NAN means? Not a number, right? So NAN. My goal is to predefine the matrix. When you remember what's the benefit of the predefining matrix? It would be computationally efficient. It'll gonna allocate the space on the memory before the program run, so that every time the program run, while loop is gonna run so many times, right? Every time the program is gonna run, it won't have to find the random places in the memory to allocate that element for that matrix. Does it make sense? So when you define it beforehand, that means you're allocating this space already, so it doesn't have to do the same thing again, wandering all around the places, right? You guys remember a little bit, you guys have a little bit knowledge about bytes, kilobyte, megabyte, how it works, 0, 1, those things. Ben, you probably didn't have, I should be talking a little bit about that. That's not part of the curriculum percent, but first of all, 0, 1, 1, 0 and 1. Computer only understands 0 and 1. You know that, right? 0 and 1 means the binary number. Binary 2, binary means 2, right? So 1 bit, if you're familiar with 1 bit, how many 0 and 1? How many places for 1 bit? 8, right? Yes, 1 bit. And then bit becomes byte, right? So 1 bit is 0 and 1. 1 byte equal to 8 bits, right? 8 of the 0 or 1. I'm sorry. Okay, so then 1 byte, then 1 kilobyte equal to how many bytes? You guys remember?
1000.
24 something. Yep. So you see, I forgot exact number, 1024
It
ish.
is 1000.
Yeah. So see, what does it mean? How many 0 and 1 in one on kilobyte? You see, 1 byte equal to 8 of this bit, right? 8 multiplied this 1024. Do you understand? So that means 0 and 1 combined make just 1 kilobyte. And nowadays, every file that you use, even a picture, several megabyte. 1 megabyte equal to how many kilobyte? Again, 1024.
Yep.
Make sense?
That's like our pizza.
Yeah, exactly. So all those 0 and 1. Your picture is actually 0 and 1. They're famous movies like Matrix. If you ever watched it, you'd be seeing like 0 and 1 all over the places. Anyway, some interesting facts. So FD, NaN once. So you have this once. If you remember, this once is a function for this matrix that you are defining. 1 Vmax. You guys remember the Vmax, right? What is the Vmax? Vmax is the maximum velocity. We did define 70 meter per second, right? So that's the Vmax, and then that's the FD. What is FD? FD is the drag force. Remember, CD is the drag coefficient. Yeah, the FD is the drag force for that CD. And then the things is still going on. So you have this variable V equal 1, and you are initializing the loop parameter as like before. Initialize the loop parameter. So while V is less than or equal Vmax, Ft V can be written as 0.5 multiplied rho multiplied V square multiplied CD multiplied A, and that's this equation for drag force, right? Again, the components of the drag force are the density, the frontal area, the frontal area, the density, the coefficient of drag, the velocity of the car, right? More the velocity, more the drag force. All right, so that's the equation, aerodynamic drag force. Let me put that. The unit first Newton, obviously, and aerodynamic drag force. Now you are familiar, right, Ben, that the Newton is the unit of force, right? So that's N for Newton, okay. And then you have this C, the coefficient, right? The rolling coefficient of friction. We'd like to define that C. Now I did write it here somewhere. I'm gonna copy it from there. All right, so make sure when we're going to write it, it just goes exactly the way I am writing. All right, so this one is unitless. Anytime you have a coefficient, that is definitely a unitless thing, okay? The rolling coefficient of friction. All right, then you have the rolling friction of the car and total force to our car. You have the drag force. Now you need the rolling force, right? And again, rolling force happen with the tire and the road contact, right? Because of that, because of that there is a friction. So the equation that can be used for that, and you see every time I'm putting a V in the parenthesis referring to the element of matrix that I'm defining for both the friction, rolling friction force and the drag force. All right, you didn't see me put any parenthesis with C or coefficient because that's a constant, okay? All right, so okay, so that's the C, and then the equation for that would be C multiplied M multiplied G Make sure you type the capital M if you define the mass of the car in capital M. So that okay, so the unit is in Newton, and so that's the rolling friction of car. Okay, then you have this Ft or total force, okay, which is very straightforward. You have this drag force plus you have this rolling friction force. You can say rolling friction force. That way you're going to understand it better. Let's put a note here surrounding around it. So it's obviously Newton in unit. There's the total force to overcome. Now who will going to overcome this? Engine, right? And what the engine consumes? Fuel. So this force we're going to get ultimately related with the amount of fuel that it get consumed on this Ford Focus, right? So that's the relationship we'll be seeing here. All right, so that's that. And then I'm going to define another variable called energy. And I'm going to write energy equal to the total force, right? Multiplied the velocity divided by 1. And don't worry about that. I'm going to explain it here. So this, first of all, that energy is energy unit in joule. Joule is capital J. That's the unit. And energy consumed in 1 second. At velocity v. So let me explain a little bit more. So this is like use this E or energy. So since v is the velocity in meter per second, the distance moved in 1 second is v meters. You guys remember, right? Like the force multiplied distance is the energy. You guys remember the unit of joule? Everybody took intro to engineering class? You should be get exposed with that. Joule, right? Joule, Newton, watt. Remember those? So the joule is like the force multiplied distance, and that's the explanation how energy is written with the total force multiplied velocity divided by 1. All right. Then I'd like to define another variable called gal per h, which means gallon per hour. So the equation that I'll be using is ideal plus 3600 multiplied by energy divided by efficiency. Remember the joule gal, that's the variable that you define. 130 10 to the power 6, that's the energy density of gasoline, that much energy content in gasoline, right? That's the joule gal, and that's the equation that I use, gallon per hour. So that's that. And then let me explain this thing a little bit in descriptive manner. So you have this gallon per hour, and which is the energy consumption per second multiplied by 3600. You know 3600 seconds in an hour, right? So that's the reason you have 3600 seconds per hour. The next variable that I'd like to define is called mile per hour, and this time I'll be defining an element of a matrix. That's why I have a parenthesis B, and then the equation that I'll be using, V, or velocity, multiplied 2.23694, and this is the mile per hour unit, mph, and we are calculating the velocity in mph. Now this conversion factor that I use, 2.23694, is to convert the velocity from meter per second to mile per hour. Okay, that's it. And once we're done with that, then we'll be writing this mpg. Okay, another matrix element, because you're seeing the v in a parenthesis, and this mile per hour v divided by gallon per hour. Okay, we just have to type correctly, then immediately it will going to show up to you. So press enter instead of typing the whole thing. There is a very good chance you're going to start typing wrong, right and left. The reason, those variables that I defined, so many variables. First of all sorts of thing I use, like cap letter, capital letter, small letter, lowercase letter. So this is a combination of everything, underscore. So that's why you should be start typing with the exact way that you typed the variable before, and then it will pop up for you to choose. You're going to choose it by pressing enter. You don't have to type it then less chance of error. All right, so you guys are catching up. All right, so the comments for this one would be, this is mile per gallon, right? And you are writing the fuel economy of car, and then the velocity. Remember, the V is a loop counter. You got to keep adding the value of 1 with the loop counter, so the while loop can continue running. So it's the increased loop counter, as like in any while loop you usually do. Okay, then you're going to end the while loop. Okay, and we are almost done with everything here, and now it's just like plotting the results, what we found. So we are first of all plotting the length. We'll first of all plot the drag force, then the rolling force, then the total force, and then the all of them would be in one figure. Okay, so we have these three different kinds of force. Okay, let's think about it again. So first of all, if the car is running, there is a drag force due to the gear. So we have the equations to find that. Then if the car is running on a road, there is a friction with the tire and the road. So there is a friction force F. There is a friction force, right? Fr, rolling friction, and there is a total force. So these three things can be plotted together, and all of them are metrics, right? Because you have the B in parentheses, and we did define it initially as B, right? You allocate before, so the program should not frustrate. This is standard way of dealing with that. Now, once you're done with that, other than those, you also found these values like the mile per hour. Okay, so that's the energy consumption per second multiplied by 3600 seconds per hour. So gallon per hour. How many gallons per hour that the vehicle Ford Focus will consume? So you should be able to find it by doing this math. Mile per hour, mpg also you can find mile per gallon. Okay, so two important things. How many gallons it consumed in 1 hour, okay, and how many miles it can driven in 1 hour. So those sort of things. Let's start to display the results. So first result is say like figure 1. You are plotting this drag force. Now the way you can do it, FD is a matrix, right? So how many element in the FD? How are you gonna find it? You guys remember? So you got to use the length function. Okay, so now here's the catch. Okay, so FD is matrix. It does have whatever amount of elements it does, right? Now, the problem is in plot you got to do x and y. So the x should be a matrix as well, right? So for x, you got to define the matrix such a way like 1 colon the length of FD. Does it make sense? You understand that? So you remember how to define the matrix by colon, right? 1 colon, that value would be like the interval of 1, right? The length of FD. So that many elements in the X matrix here for this plot. So you should be writing this length and this FD, right? Now you don't have to put the V on a parenthesis here. You understand that? The reason is like FD itself is the matrix, right? Now this would be with this FD itself, like the value of the FD in y-axis, and then you'd like to put a comma, and then you can put the marker size, marker style, whatever you would like to put, right? It's up to you. But I will gonna do something like say like line width, just to remind you how to change the property, and make sure you put the L and W capital letter, right? You remember, like line width or marker size, or font size, font type. Every time like font size F and S should be capital. Font type F and T, right? The same thing is line width. All right, and then you have this hold on function need to use. Remember that what the hold on does. In a figure, you have one plot now. You have to do multiple plots, then you'd like to use this hold on function. What are the other plots you'd like to put? So what are the other things that you got to do? Like the rolling resistance, right? So kind of the same thing you would be using or doing. So let's put it this way, but instead of D, you'd be changing it to R because it's the rolling resistance force, right? And then you'd like to use the hold on again, right? And then you'd be using the plot. All right, so then the last one would be the FT or total force. Okay, and then you'd like to put some levels. So X level, you'd like to put on X level the speed. Okay, so speed, mile per hour, Y level, fuel economy, mile per gallon. Title, so fuel economy as a function of speed. I hope I had an error, but I've got to figure it out. So V equal to V, error is it running for any of you?
No,
Is it running for you?
I have the same error. Mine, well, mine's a different line, but same area. Mine's at that through line 50. That MPG.
You have an error here?
Yeah.
Okay. Let me see. I'm trying to figure out. I do have an error as well. I should have error. I have the notes here which was running in perfect condition before. But it happened when I'm typing. There could be error for whatever reason. I'm not seeing anything visually yet that could trip up this error, but you never know. Alright, so there is a way around. Okay, what does it say? Operator. Oh, there is the operator that I use. Non-conformant argument call from line 50. So that colon operator and I use here this colon operator that's there referring actually 1 comma colon. Alright, let me see. I gotta do a little bit of command window. I do have FT value somewhere. I had the FT value. It doesn't go that far. It just have 2 times it calculate the drag force. Okay. Why? FT ever. Okay. only this thing calculated twice. Gallon per hour. Is it running for you, Ethan? Not either. Alright, so okay, so I have this thing 70. This should be running 70 times, and the V is less than equal V max. That's perfect. So V max, this is not running 70 times. So something happened when it comes here. Okay, mile per hour, V gallon per hour. Okay, so maybe I can put it. I don't need it. Run. Okay, so it's running. I mean, whatever happened in line 50, I have to figure it out. Something happened here in line 50. Oh yeah, I know what happened. It needs to have uh, it shouldn't, because these are the elements, right? What is the gallon per hour? No, it shouldn't have this issue. Okay, let me see. No, that's the non-conformant. Okay, why is non-conformant? So gallon per hour. So I have this ideal constant value, energy constant value, efficiency constant value. So energy, oh, it's a constant value every time the wheel gonna run. Oh, this FT, oh, here. The problem happened here. So energy, that's the typo. Everybody, please correct it. There should be a V here. So that's the mistake I did. And now it should run. Got it? So there's the important lesson here. See, even though it shows here the problem is at line 50, but you got to explore why this line 50 is not running before. Does it make sense? Yep, that's it. And I'll start with this, symbolic math today. Or if you want, I mean, you can skip the symbolic math now and just finish it all together on Monday. It's not that big. You guys, but I can give you some homework for that. Maybe it's better to start today, right? That way, what do you think? I mean, you see, you don't have that much to do, right? If you're gonna finish this homework, then next week you can deal with one homework, and by week 15 beginning, right? You can finish the exam, right? Not that much, not that you have to deal with the project or anything. Your choice. If you prefer that way, then I'm gonna end this class now. If you want me to go with the symbolic math, but I'm gonna give you some homework, okay? So, yeah, let me give you some homework. What you're gonna do in symbolic math. I mean, the theory part. And it's not like the theory that you absolutely need to know, but it's something that you have done it in calculus all the time. Remember, you have like sets of equations. Say like you have two unknowns, two equations. You know that, right? So if you'd like to get solved, if you have like two equations, how you can do that? Usually, manually, it's like convert something, right? You have done it before analytically, like pen, paper, and some calculator. They have the options. You have to use that for the field, right? If you have like two sets of equation, x and y value, you can find it, right? If you have like four equations, then four x, y, z, whatever, right? Z, t, four variables, you can find it. So more number of equations must needs to be matched with number of unknowns. You know that, right? So that is one thing. Okay. The other thing is like, you remember the quadratic equation is solved here? Like ax squared plus bx plus c equal to 0. Then the x has two value. Remember? So you can use the symbolic method to solve that as well. Okay. Not only that, like differentiation, integration, you can do it by symbolic method. Okay. So my homework for you guys to review those things what I just said, right? Differentiation, you can do differentiation twice. right? So review those things like in general, like I don't know, maybe see some examples from Khan Academy or whatever, right? So or from your calc book, like or get it from online. Whatever the source is, review those. What I just said, right? Sets of equation, quadratic equation. Remember, sets of equation means like if you have two equations, two unknowns, how to solve it, those sort of thing, right? You don't actually have to give the equations how to solve it. There's a function for that. That's why it's symbolic math, right? That's the beauty of this program. So you just have to write that function name, it will solve it for you. Just have to give those two equations, okay? The same thing is for quadratic equation, differentiation equation. So do those homework, right? Do a quick review before Monday. So when time comes on Monday, that that time we're going to see how to use the functions to solve this symbolic. And then I'll upload the homework. It is no point for me to upload the homework now if you haven't done anything today. Okay? Alright guys, if you don't have any question, maybe it's time to end the class. Ben, you got the plot?
Yep.
Okay, perfect. Alright, let me end the recording. Hopefully Jason will gonna listen to the recording.